to make factorial design in Design Expert software or Statis software easily. This will be the easiest video you'll ever see in YouTube regarding the explanation of using Statis for factorial design. So let's begin with opening the new design and see. This is the basic all this is basically all the designs that are available in the Design Expert software. Okay, first of all, there are factorial, randomized, and multi-run, minimum run, multi-level categoric, and regular two-level factorial design, which we are going to use in this video. So first of all, I'll explain you by using some examples regarding the factors and responses that I'm using in this video. Okay, so first we'll choose 2 cube. Okay, this is 2 cube design, or you can choose any of the design. I'll choose 2 square design. Okay, next, so first factor I'll be putting as phospholipid. In mg, the lowest will be 100 milligrams and highest would be around 300 milligrams. Okay, and the second factor that I'll be using here would be cholesterol in mg, and cholesterol would be minimum 2 mg and maximum of 100 mg. So I've chosen 2 factors. By choosing vertical, you can vertically arrange the table, and that's nothing. So let's move forward. So here I'll be choosing 3 responses. Okay, for first response I'll choose particle size, which is in nanometers. Difference to detect data signals. Okay, the second response I'll be choosing zeta potential. Okay, in microvolts. The third response I'll be choosing entrapment efficiency percentage. Entrapment efficiency. Okay, so from here we can edit the model. We can see the responses. First, only interaction of phospholipid and cholesterol. By right clicking here, we'll select it as a model. Okay, so this is basically how you input the factors in the factorial design model. Okay, so let's move forward. Power not defined when the residual. Okay, so let's finish this design. So here it is giving us only 4 runs, and the minimum value which we have selected is 100, maximum value is 300 for phospholipid, and for cholesterol it is 2 and 100 respectively. So because we have chosen only 2 factors, it is showing only 4 runs. If you've chosen more than 2 factors, or like 3 or 4 or 5, it would have given you more than 4 runs, like either 16 or 18 or 20, like that. Okay, and after getting these responses, you have to perform all these 4 runs for your experiment, and after performing those experiments, you have to measure the particle size of all the 4 runs, their zeta potential, and their entrapment efficiency, and you have to insert those values in these columns. Okay, and after inserting those values, you can analyze this factorial design that you have created from here. Here on clicking analysis, you can analyze all the responses. So after analysis, this software will show you the responses, like particle size, what is the effect of phospholipid and cholesterol over the particle size, and similarly over the zeta potential and over the entrapment efficiency. Here I will show you how to make graphs of the previous factors and responses that we have entered. Now we have to enter the responses for the resultant factors that we have put here. So the particle size of this was like 98 nanometer, 98.45. I'm just entering all the factors, all the responses as an example, just to show you what and how the graphs are made if you put the responses like this. Okay, it's just an example. It's not a good value. It's not exact value. Okay, zeta potential. zeta potential would be 123 point. So basically when you put responses like this, you have to put all the values near to each other, and by doing so you will get good graphs. Okay, and entrapment would be 89. See, now I have put all the responses of particles, zeta potential, and entrapment. Now I have to analyze the responses, and for analyzing I'll first check the notes, no comments by the software, and then summary. What type of runs are we having? How many? 4. What is the type of these designs? Randomized factorial design. Okay, and 2-level factorial design is used, and design model is 2F1. Okay, and there are no center points in this, and these are all the minimum and maximum values that I have put in the factors. And let's check the custom graphs. This is basically the graph. There is of no use to me now. And from evaluation you can select all the things that you have to make the model of. Okay, and let's go to the analysis part. First of all, we'll start the analysis of particle size. So this is the half normal plot. From here you can select the layout of the graphs, and from here this layout must be used. And see, in this table we are seeing that all these factors are not selected as a model. These are selected automatically by the software as error, and if they are selected as error, I'll show you. You cannot make graphs when they are selected as error. For example, where's the graph? See, model graph. See, it is saying that you have not selected any factors for the model. The model will contain only the mean. Do you want to continue? So no. So from here we have to select these 3 factors as model, and after this you can see the ANOVA. See, there is no f and p value because there is not enough data for the software to calculate and tell us that if the p value and f value is either correct or not. And also the adjusted and predicted r square is also not showing, and the reason for that is that there is not enough data in the design. See, there are only 4 runs, and there is no longitude of variation in these runs. That's why it is not showing the f and p value and the r square. So you don't get any enough coded and actual equation, but the graphs can be made by this. Okay, and if you enter the actual values of the responses here, and if you get more runs than 4, then you will be easily getting the p and f value as well as the r square value. Okay, so now basically let's hop on to the graphs. This is the interaction of the cholesterol and phospholipid, which is actually null. They don't show any. So let's check the predicted and actual value. This is the predicted and actual value, and as you can see, because of minimum number of runs, this value is actually quite nice, because for the predicted and actual value to be good, you should get all the points near to the line, and it is near to the line, so it is good. Let's check out the contour graph. Okay, you can zoom in this section like here, and you can select the runs from here, and you can select the interaction. Okay, so basically we have to select AB interaction, and you can see that this contour graph shows the relation between phospholipid and cholesterol, and what effects do they show to the particle size of the formulation that you have made. So basically, how do we read the contour graph? We read by seeing these points, like the particle size is 98 nanometers when the cholesterol is above 30 mg and the phospholipid is below 200 mg. So this is how we read the contour graph. Let's move on to the 3D surface graph. This is the 3D surface graph. This is for the interaction of AB and randomized run selected. For example, if you select run 1, this will be like this. If you select run 3, the graph will change a little bit, not too much, because we don't have sufficient runs for it to change. And this graph can be easily copied or exported to the Word or PowerPoint. Okay, you just have to open a Word in the background, and by exporting to Word, exporting graph to Word, the graph will be easily copied in its actual pixels to the Word, or you can either copy it by pressing the OK button. Okay, and let's analyze the zeta potential. Start analysis. Same as there, as we did in the particle size section, we have to select this layout, and we have to select all these factors as model, and after selecting them as model, we have to go to ANOVA. No enough value for the p value or f value to be available and not enough data to predict or adjust the R-square value. Move on to diagnostics, move on to graphs. Let's check the contour graph. This is the contour graph for zeta potential. This is the predicted versus actual value, which is actually good. And this is the 3D surface value. And it is also a little bit off to the side. You can copy any of these graphs by right clicking at it, okay, or exporting it to the Word or PowerPoint. Now let's move on to entrapment efficiency. We'll do the same here. Okay, I've not selected the models. First we have to select the models from here. Right click, model, okay, and now run to the ANOVA, diagnostics, model graph, check out the predicted versus actual value, good, contour graph, and 3D surface graph. So this is how you make the graphs in factorial design, okay. And if your values are very good, and if you have got more than 4 runs, you can optimize this design by checking these numerical values. You have to put the values of phospholipid lower and upper value, and then whatever the values of phospholipid have come, it will show here, okay. And in the graphical section you have to put the lowest and upper value of particle size, and whatever the size of particle come in between them, it will show that formulation is optimized. So okay, that's all for today. Thank you so much for watching. Do comment, subscribe, and like my YouTube videos and channel. Thank you.